Close your eyes and imagine you are standing at the edge of a great ocean of silence. The waves move softly, but they don't follow the rules you know. They ripple forward and backward at once. They shimmer, fade, and then return, as if time itself has lost its rhythm. This is the ocean of the quantum world. Strange, unfathomable, yet profoundly real. A realm where everything works with extraordinary precision, and yet nothing makes sense. Quantum physics has been called the most successful scientific theory ever created. Its predictions are flawless. Its technology shapes every corner of our lives, and still, no one truly understands it. So tonight, let's wander together into this quantum dreamscape, not as scientists, not as problem solvers, but as dreamers, as travelers who simply want to float in the mystery, to let the strangeness loosen our minds, and to drift gently into rest. In the everyday world, the laws of physics feel solid. Apples fall from trees, clocks tick in steady rhythm, bridges hold our weight because matter is reliable. But beneath this layer of certainty lies another stage, a stage so small that even atoms are like galaxies in comparison. Here, the laws of Newton and Einstein fade into whispers, and something stranger takes their place: the quantum stage. Here, particles are not tiny billiard balls neatly rolling across a table. They are more like clouds, like smudges of possibility. A single particle can be in two places at once. A photon of light can travel every possible path simultaneously, until, only when we look, it chooses one. Reality at this level does not sit still. It hovers, undecided. It is both here and there, both yes and no, both awake and asleep. Like a dream, it waits for attention before it takes form. Perhaps the most famous parable of quantum strangeness is Schrödinger's cat. Imagine a sealed box. Inside is a cat, a vial of poison, and a quantum device that has a 50% chance of breaking the vial. Until the box is opened, quantum physics insists the cat is both alive and dead. Not one or the other, both. It sounds absurd, almost cruel, and yet it illustrates something profound. The act of observing doesn't just reveal reality, it creates it. The cat, like the quantum world, exists in a cloud of possibilities until someone looks. The moment of observation collapses the mist into one definite outcome: alive or dead, wave or particle, yes or no. Perhaps our own lives carry echoes of this truth. Futures unopened, choices not yet made, all existing together, side by side, in a haze of possibility, until we look, until we decide. You too are Schrödinger's cat, in your own quiet way, alive in every path you have not yet taken.
One of the most haunting experiments in all of science is called the double-slit experiment. A beam of light is sent toward a screen with two slits. If we think of light as particles, like tiny marbles, it should pass through one slit or the other and form two bands on the wall behind. But that is not what happens. Instead, the light forms an interference pattern, a ripple of waves overlapping, as though each particle of light traveled through both slits at the same time. And then it grows stranger. When we try to watch, when we place a detector at the slits to see which path the light takes, the interference pattern disappears. The light behaves like particles again. It is as though the universe itself resists being pinned down. It whispers, "You may look at me as a wave or as a particle, but not both at once." The very act of observation changes the outcome. Close your eyes and picture that. a universe that bends itself around your gaze, a cosmos that waits for you to look before deciding what it is. Light has always been a mystery. Ancient poets called it the breath of the divine. Modern physics calls it photons, quanta of electromagnetic energy. And yet it refuses to be just one thing. Sometimes light moves like a wave, fluid, endless, spreading across space like ripples on a pond. Other times it hits like a particle, a sharp packet of energy, distinct and undeniable. Wave and particle, continuous and discrete, both and neither. This is the dual nature of reality revealed through light itself. The reminder that the universe is not tidy, not neatly labeled. It is a shimmering paradox, refusing to choose just one mask. And maybe that is why the night sky feels so alive. Every star you see is not just a burning ball of gas, but a quantum orchestra, a chorus of particles and waves singing across space. When you lie under the stars, you are lying under paradox made beautiful. If wave-particle duality is strange, entanglement is stranger still. Imagine two particles born together in the same moment of creation. You separate them, sending one to the other side of the room or even across galaxies. And yet when you change one, the other responds instantly. Distance doesn't matter. Time doesn't matter. They are forever linked. Einstein, baffled by this, called it spooky action at a distance. But quantum physics insists it is real. At the deepest level of existence, connection is stronger than separation. And perhaps that is true not only of particles, but of us. Every bond you have formed, every memory you hold, every love and every loss, are they not a kind of entanglement? Threads that stretch across years, across miles, yet still tug gently on your heart? Maybe loneliness itself is an illusion, for in the quantum world, nothing is ever truly apart. At the heart of quantum mechanics lies the idea of superposition. A particle does not choose a single state until it must. Until then, it rests in a twilight zone, both here and there, both moving and still, both everything and nothing. Imagine a coin flipped into the air. In the world you know, it must be either heads or tails when it lands. But in the quantum world, the coin remains both at once, spinning in possibility, never collapsing until your eyes fall upon it. Superposition is the poetry of potential. It whispers that reality itself is a canvas unfinished, waiting for the brushstroke of observation to give it form. And perhaps your own life mirrors this truth. The decisions not yet made, the dreams not yet chosen, all exist in a soft field of maybes. You are not only who you are now, you are who you could be, suspended in the shimmering mist of possibility. Close your eyes. Feel yourself stretched across paths not yet taken, across futures that glow faintly, waiting. Superposition is not only for particles, it belongs to you too. When we hear the word vacuum, we think of emptiness, a void, a space where nothing exists. But quantum physics tells us the vacuum is alive. Even in the deepest emptiness, particles flicker into being and vanish again. They are called virtual particles, ghosts that appear from nowhere, live for a breathless instant, and dissolve back into silence. This seething nothingness is called the quantum foam, a restless energy bubbling beneath reality, a reminder that the universe is never still. Perhaps the same is true within you. Even in the quietest moments, when you feel empty, when you feel drained, there is life flickering within, thoughts forming, dissolving, hopes whispering, retreating, a subtle energy that never truly leaves. So when you feel hollow, remember,
Even the void is alive. In the everyday world, walls are solid. A stone cannot simply pass through a wall. A person cannot walk through a locked door. But in the quantum world, barriers are softer. A particle facing a wall does not simply stop. It lingers at the edge, like mist pressed against glass. And sometimes, impossibly, it slips through, appearing on the other side as though the wall was only a dream. This is quantum tunneling. Without it, the sun itself would not shine. Deep within the sun's core, protons fuse together to create light and warmth. But by the rules of classical physics, they should never overcome their repulsion. The walls between them are too strong. And yet, through tunneling, they pass. You are here, listening, breathing, alive, because particles learn to tunnel through impossible walls. And maybe this, too, is a lesson for your heart. The walls you face may feel unbreakable, but sometimes, just sometimes, life slips you quietly to the other side. Heisenberg's uncertainty principle tells us something both strange and soothing. You cannot know everything at once. You can know where a particle is, but then you cannot know how fast it moves. You can know how fast it moves, but then its place in space becomes a blur. Precision in one means uncertainty in the other. Reality is built not on clarity, but on limits, on the impossibility of perfect knowledge. And maybe that is a relief, for how often do we demand certainty of ourselves? To know where we are going, to know who we are, to know everything at once. But the universe itself refuses such clarity. It moves in mystery. It allows us glimpses, never the whole. Perhaps we too can rest in uncertainty, letting go of the need to measure everything, allowing ourselves to drift, not always knowing, not always defined. Uncertainty is not failure. It is nature's way. Time feels like a river, flowing forward, never backward. Past behind us, future ahead. But in the quantum world, time does not always obey. In certain equations, particles can move not only forward, but backward. They can borrow time, bending it, reshaping it, living in ways we cannot fully imagine. Some physicists whisper that the past and future are not separate, but entangled, that the present is a veil, thin and shimmering, stretched across deeper truths. Perhaps you felt this, a memory that still feels alive, as though time folded back upon itself, a sense of déjà vu, as though the future had already brushed your mind. In the quantum dream, time is soft clay. In your dream tonight, time can soften too. Past, present, and future dissolving into one quiet moment, the now. Quantum mechanics carries a haunting thought. Does reality exist before we look at it? The equations suggest that particles remain in limbo, superposed, uncertain, until an observer appears. It is as though the universe is a stage, and the play will not begin until someone enters the theater. Some scientists argue the observer could be anything, a detector, a camera, a measuring device. But others whisper that consciousness itself may be entwined in the fabric of reality, that the act of awareness plays a role in shaping the world we see. Close your eyes and imagine this. Each time you notice a flower, a star, or the flicker of your own breath, you are not just observing reality, you are completing it. You are helping the cosmos choose a path. What happens when you look in a mirror? You see yourself, solid, certain, defined. But in the quantum realm, particles act like mirrors to each other. They reflect possibilities back and forth, exchanging information without touching. Sometimes what one particle knows about another cannot be explained by any physical connection, only by the mathematics of entanglement.
It is as though the universe is filled with mirrors, each particle reflecting, echoing, and answering another. And maybe we too are mirrors for one another, reflecting emotions, memories, and quiet truths. When someone smiles at you and you smile back, you are entangled in a human quantum mirror. At the smallest scales, even space itself seems to shimmer. Zoom in far enough, beyond atoms, beyond particles, and you reach what physicists call the Planck scale. Here, space is not smooth. It is a frothing sea, a quantum foam, bubbling with tiny fluctuations. Space-time itself becomes uncertain, wrinkled, alive. The universe is not a quiet void. It is a restless dream. And perhaps your own mind reflects this. Beneath your calm, beneath your sleep, your thoughts bubble like foam. Tiny flickers of memory, sparks of imagination. Restless, yet beautiful. Even silence has a pulse. Before observation, particles exist as waves of probability, everywhere at once. But the moment we measure, the wave collapses. The shimmering mist hardens into a single outcome. The collapse of the wave is one of the strangest riddles in all science. What chooses the outcome? Why this reality and not another? It is as though the universe is constantly narrowing itself down, collapsing infinite dreams into one present moment. And perhaps this mirrors your own life. You too are a wave of possibilities. Each decision, each glance, each breath collapses the wave into the next chapter of your story. You are not only who you are, you're the outcome of countless waves, collapsing, gently, into now. In the world of Newton, everything has a cause. Push a ball and it rolls. Heat water and it boils. The future follows the past. But in the quantum world, randomness reigns. A particle may decay now or 1,000,000 years from now, and no law decides when, only chance. This randomness is not ignorance. It is built into the fabric of reality. The universe itself carries unpredictability at its heart. And yet randomness gives rise to freedom, to newness, to creativity. If the cosmos were perfectly ordered, nothing unexpected could ever bloom. Perhaps your own surprises, the twists and turns of your life, are not mistakes. They are quantum whispers, reminders that even the smallest randomness can create new worlds. There is a strange effect in quantum physics. If you watch a system too closely, you can freeze it. Imagine a particle that should change state, flipping back and forth like a pendulum. If left alone, it flows naturally. But if observed again and again, relentlessly, the change slows until it almost stops. This is called the quantum Zeno effect. Watching too much keeps the system from evolving. Perhaps this is true for us as well. When we scrutinize ourselves constantly, demanding progress every moment, we feel frozen. Growth hides under too much observation. But when we soften, when we look away, life moves again. Change blooms in the spaces where we stop measuring ourselves.
In quantum mechanics, particles can borrow energy from nothing. They pop into existence, live for the briefest instant, then disappear again. Physicists call them virtual particles. They are not quite real, yet not entirely unreal. They ripple in and out of the vacuum, as though the universe is breathing at its smallest scale. Without this borrowing, atoms could not exist, stars could not burn, life could not rise. And perhaps you too borrow energy from unseen places, from memories, from hope, from moments of beauty that appear and vanish, but leave a trace within you. Even the fleeting can be enough to hold the universe together. In the quantum world, superpositions thrive, particles in many states at once.
But in the large, visible world, superpositions vanish. Cats are alive or dead, not both. Coins land heads or tails, not both. This transition from quantum to classical is called decoherence. It is the fading of quantum dreams into everyday certainty. It is as though reality itself is a sleeper, drifting from dream into waking, where choices narrow and possibilities collapse. Perhaps each morning, when you open your eyes, you too undergo decoherence. Infinite dreams fading into the clarity of one life, one path, one today. And yet, the dreams never disappear. They linger softly beneath the surface. Physicists tell us that particles are not the most fundamental things in the universe. Beneath them lie fields, vast invisible oceans that fill all of space. The electron field, the photon field, the Higgs field. Each particle is a ripple, a crest, rising briefly in a boundless sea. You are surrounded by fields, bathed in them, shaped by them. What seems solid is only a wave and a deeper ocean. And maybe you, too, are a ripple in something greater, a crest in the ocean of life, brief but beautiful. When you drift into sleep, imagine yourself dissolving back into that hidden ocean, resting as part of the field. Everywhere you turn in quantum physics, answers lead to deeper questions. Why does the wave collapse? Why does entanglement ignore distance? Why does reality seem to require an observer? No one knows, and perhaps no one ever will. But maybe this is the gift of quantum physics. It restores mystery to the world. It reminds us that beneath the surface of things, beneath the routines and certainties, there is wonder, there is strangeness, there is beauty that cannot be explained away. Tonight, as you close your eyes, let yourself rest in that mystery. You do not need to solve it. You do not need to understand. It is enough to float in the not knowing. For all its strangeness, quantum physics works. It works so precisely that our entire modern world relies on it. Your phone, your computer, the satellites that guide GPS, all of them run on quantum principles. MRI machines, lasers, semiconductors, all born from equations that describe particles flickering between states. And yet, the mystery remains untouched. Scientists can calculate quantum predictions with extraordinary accuracy, but ask them why it works. Ask them what it means, and you will hear silence or laughter or wonder. The most successful scientific theory in history is also the least understood. Perhaps that too is a kind of lesson, that you do not need to understand everything for it to support you, to guide you, to bring light into your life. Quantum physics is not only about equations, it is about wonder. It is about standing at the edge of mystery and letting yourself be small, letting yourself be amazed. It tells us the universe is not rigid, but soft, not fixed, but flowing. That what we see is only one slice of a much deeper dream. So as you drift towards sleep, imagine yourself dissolving into that quantum sea. Your body no longer solid, but a cloud of shimmering particles. Your thoughts no longer fixed, but spreading like ripples through water. You are both wave and particle, both question and answer, both awake and dreaming. And gently let that strangeness carry you, not toward answers, but toward rest. Not toward certainty, but toward peace. The quantum world is strange. It works, but it makes no sense. And maybe that is the greatest comfort. That you too can rest without needing to solve yourself. That you too can simply be mysterious, uncertain, beautiful. Good night, dreamer. Sleep well in a universe that shimmers with possibility.